Hello, Cardstack community. My name is Chris C., the founding director of the Cardstack project, coming to you from the land of the Web3. Today, I'm joined by Nillion Chief Scientific Officer Miguel de Vega to talk to us about a new primitive that allows us to do decentralized computation and storage in a private way that augment the capability of the current decentralized ledger or smart contract infrastructure that is both based on that primitive that we have, but also extended beyond use cases that may be just outside of the reach of the current stack. So it's really, really excited to be able to hear from someone at the front line, not only in products and thinking and community, which is what we focus on right now in Web3, but also a real breakthrough and augmentation with scientific thinking to say, how can we push this frontier forward so that Web3 as a technology and as an ecosystem, and certainly as a promise, can be richer than what we have today. Welcome. Yeah.
Thank you, Chris. It's a pleasure to be here. Thank you so much for the invitation.
Absolutely. It's really fantastic to talk to people who are working on the actual problem solving, not just applying the problem that's already been solved in new ways, but actually identifying the problem. So can you tell us a little bit about not just like what you have come up with in terms of the solutions, like what is a problem that drawn you to this project or this particular area within the protocol stack, and what you're trying to solve with it? Like what are the things that make you feel like it needs something that you're delivering right now?
So when you look at the web the way it is today with the current version 2, I think there's two unwritten rules that no one or very few people talk about, but they do matter a lot. The first one relates to the current version of Web3, which says more or less that if you want to receive some service from the web, you have to trust the service provider, because they have full control over that service that is being provisioned to you. They can change it anytime they want without even your knowledge or consent. So that is more or less the what is addressed in, with blockchain technology, because now there is a protocol and no single node can actually interfere with the functioning of that protocol. And the provisional of the service is more or less guaranteed. But there's a second one that is equally important, which more or less runs like, if you want to get something from the web, you have to give something to it. And what you give is your information in terms of data. So we're not talking about paying money. Right. We're talking about really giving your data back. Every gesture you have with your mouse, in order to, exactly. Everything is being monitored.
IP address, which is a proxy location, and the device you're using, fingerprinting your operating system. Yeah.
And the scary part is that this is an irreversible process. So the moment you have shared something with the service provider, it's something you cannot take back. It's something that they have now full control over, and that they can do with that information whatever they want. And so it is the combination of those two things, I think, that led into the problem space of Nillion.
So it's interesting to think about Web 2 as requiring a tremendous amount of trust, right? They can modify your document, they can stop your access, they can block your account. With Web 3, with smart contract, you're basically saying these smart contract and protocol are kind of already deployed, and it is available for anybody who uses it, runs a node, or through a node provider to do that. Talk to me a little bit about the privacy assumptions that people have on Web3, which is that in exchange for that reliability, I'm going to tell you my financial holding. I will let everybody know what I own and stuff like that. And that I think is great. And it's upside of people really, really look at that as a badge of honor. People live online today, and if you live on chain, you have an assumption of privacy that is taken away from a community building and a kind of reputation building. It's like, this is my ENS name. You can see how I trade, and that's pretty cool. I don't think that applies to everybody, and certainly doesn't apply to all the use cases. So tell me a little bit about the privacy angle that is maybe either missing or potentially a nice additive to the Web3 ecosystem today.
Yeah, that's a very good point. In a sense, the first version of the Web 1, back in the 90s, is very similar to Web 3, because both were, Web 1 was very, it was mostly public, and it was hard to run complex logic on the browsers because they didn't have the support for that. So the consequences is that the privacy mechanisms that you could implement on Web 1 were very, very primitive. With Web 2, what happened is that browsers became more powerful, and now you could implement all sorts of advanced privacy mechanisms like, secure authentication and secure payments and all of that. And one could argue that that is the key ingredient that enabled the Web 2 to reach, the size that we see today. And the funny thing is that in going from Web 2 to 3, we have kind of left that ingredient aside because most Web 3 technologies are public. That is good for some use cases where you require public accountability, like all things related to the management of digital assets. It's generally a good idea to have, as I say, that public accountability there. But as soon as you try to get away from those use cases and go back to the Web 2 use cases that you had, you find the problem of how do you deal with private information in a decentralized infrastructure. It's a very hard problem that I think the current infrastructure from Web 3 is not currently addressing or solving.
Yeah, and there's some accidental discovery of that gap is like, for example, someone is like, getting paid in in working in Web3, and then they was using banking system, and then they just say, hey, I'm going to start getting paid using USDC, which seems equivalent. And then you realize all your coworkers know how much you make, like instantly. And that's okay to some people, and some people find that to be kind of like a big shift, a larger shift in an expectation of the software stack that we work with or the services we use than maybe a settlement in a coin USDC or settlement in USD.
Yes, another place where you see that is to control all those assets, you need some advanced authentication mechanisms. And in a sense, Web3 is going back to one-factor authentication. So you have a cryptographic key that controls your wallet. But as soon as you want to tie that key to something more palatable to humans, like your biometric authentication, or let's say some password, or let's say your geolocation, all those things, then you need to go back to the centralized world. So those services are being provided now from the centralized world, which kind of defeats the purpose of decentralization, because the key element that allows you to operate your decentralized wallet is centralized.
Yeah, or even partially centralized. If there's there's been discussion about account abstraction. I gave a talk in ETH Dubai about introducing hybrid custody. It's just as what if a service provider can do things when you're sleeping and you have control over it as well? There's an assumption there's a service provider on the other side controlling the other part of those signing messages. And that idea of having to trust a second party, unless it's for one factor, which has all the lose your coin, lose your key, lose your coin compromise. How much do you trust yourself? There's an element that there is trust that you can gain from in the control of asset with third party. The question is, are those third party necessary need to be companies, or can they be more than that? So in your vision, let's start, there's many layers of decentralization. And you mentioned this idea of accounts and wallet and authentication. And people come to understand the nature of owning your own digital asset on one hand, storing your balance in FTX and getting him disappear, or even storing your cash at Silicon Valley Bank and having it possibly disappear. The people are starting to sense that, hey, they may want to control their own assets. On the other hand, they also like the fact that they don't trust themselves, and therefore they did it in the first place. Mattress under the money under the mattress wasn't the preferred choice ever, and still won't be in the future. Can you tell us a little bit about, how multi-party computation was kind of brought in as a way to deal with this key signing problem, which is just who is able to control that? And that's kind of like where it was beginning before the smart contract wallet became kind of the thing because Ethereum's current structure. Can you tell us about the nature of decentralization of the control of asset? How has that evolved, and what is the current state right now?
Yeah, so secure multi-party computation is a cryptographic primitive, and is one of the few primitives that from the beginning it talks about a network of nodes. So it means that it's a very good starting point to build a decentralized network on top of. And what it enables these nodes to do is to actually perform computations on data without seeing that data. So imagine there's a secret that it could be the private key. The nodes don't see that private key. What they see is some hidden version of it from which they cannot actually go back and reconstruct the key. But working on those hidden versions, which are called shares, they can essentially perform the signing on your behalf so that you can get your transaction signed without having anyone see your private key. But it goes beyond that, actually, because secure multi-party computation is a general purpose framework. The reason why we've seen applications only in some specific use cases, one being wallets and another one would be interoperability between blockchains, is because SMPC typically encounters some scalability problems. If you want to compute something complex, the nodes need to exchange a lot of information, and that makes the process slow, and therefore there's only a limited number of use cases that you can address with SMPC. And that's where more or less NMC comes in. It's the Nil Message Compute.
Yeah, it seems like what's actually possible has to be done in a way where the mathematics for that computation across the node has to be limited to a certain type of breakthroughs. Like now we can do M of n multisig type of computation using this kind of curve function or something like that, arithmetic in a way. But it's not general purpose. You can't calculate, what your astrological science is based on some detection, and that it's only restricted to a small number of computation that would be for signing, basically.
Yeah, but for practical purposes, for the practical purposes that I'm talking about, it is because it's not because MPC is unable to perform those computations. It's actually Turing complete. It's more because as soon as your computation is a little bit complex, then it's very slow. So it's a little bit more like, okay, let's find the easy problems we can tackle with this technology so that it doesn't show that it's so slow. And that's why it is very interesting.
It's
to
hiding a limitation.
Exactly. Let's find the use cases where this is actually feasible. But it's not because there is some inherent thing in MPC that prevents it from running, any general purpose logic.
Given that as like a foundational aspects of a cryptographic primitive that's pretty widely used, I'm really excited about the new launch of TBTC, which uses the multi-party computation for a network of nodes to secure Bitcoin in one chain and make it available as a tradable TBTC token on another chain. And that type of kind of control is better than trusting a company holding a bunch of Bitcoin in a single sig or even multi-sig wallet to not take them or have them there, right? So that's a nice primitive. Going into the new use cases, the one that may actually start taxing the communication overhead inherent in that generation of MPC, what is the missing piece that I'm sure you guys are thinking about that will allow us to break through that limitation that exists despite its Turing completeness and ability to do almost anything, but because of the scalability concern, we are not kind of exposing that capability. What is the thing, the new primitive that allows us to imagine this multi-party communication to actually attack some either use case or algorithm that actually expands a use case beyond just signing a multi-sig?
So we think that primitive is NMC, which stands for Nil Message Compute, and is the core technology behind Nillion. It's an MPC type of derivative or byproduct, but it combines it also with homomorphic encryption. So it is in the combination of the two that we are able to run computations at scale with much less communication than in MPC. And in some use cases, absolutely with no communication at all. We think that that's transformational because it means that now your computer, the computers in the network, as soon as they get the information they require for the computation, they can run as fast as the CPU allows it, rather than having to wait for messages to go, back and forth between them, and therefore have an experience that is much closer to what you would expect from a centralized infrastructure.
Right. So, from reading the white paper, it seems like the way the nodes are running the computation is that they get the raw ingredients for the computation from the networks through some sort of kind of like gathering scheme. And then they can run the computation locally as if it's on a single machine. And then when they're done, they kind of submit it back to the network for commitment, for the results and stuff like that. So that's my general understanding. Is that roughly accurate?
Yeah. So it all begins with the data, the input data to the computation. So either there's users outside, or maybe it's one, but maybe it's more than one, sending that information over to the network, but always never in encrypted form, never in plain text form, but always in this secret shared form. In our case, we use something slightly different, which is what we call particles, and it's a super secure way of sending information to the network. Or you could have that information already from a previous computation, or because it's stored there in particle form. So those are the two ways to inject information into a computation. Then the nodes, as you said, they operate in locally with that information. They crunch the numbers. They just independently go and get one or several results. Those results are still hidden in that form of particles or shares. And then the nodes talk to each other in order to provide the information to the result node. The result node could be either the same as the one dealing the information, or it could be a third-party provider. It could be really anyone. So that third party gets the information from the nodes in the network, and then is able to locally reconstruct the output of the computation by running something called error correction. And you can think of that as the moment where consensus takes place. So in a blockchain consensus, you have this monolithic structure, which is the ledger, and the state of that structure is agreed on based on consensus, which is something that continuously run. Here we have something slightly different. Consensus just pertains to the output from a computation, and it just takes place for that computation. So it's not something global. And that has tremendous implications as to the structure of the network, because now you can build a network using clusters, and every cluster can work and operate independently from one another, rather than all of them having to communicate at some point. Even if you have a layer 2, all of that needs to kind of go back together and be agreed on using the consensus. But we don't have that, because you can run consensus just locally on the output from every computation, and that makes the network much more scalable in a sense.
Right, and I think the need for like a centralized sequencer, we built layers like layer 1, layer 2, but they're all centralized sequencers. So you can have multiple centralized sequences kind of like merging in traffic, 5 lanes into one, but it's still a merge of some sort. It's not like roads that run in parallel to each other, then you can have an unlimited capacity. It is still a funnel of some sort, no matter how many layers you add.
Exactly.
Right? If you have a centralized sequencer as an assumption.
Exactly. At the end of the day, you have all those lanes go to the city. They go through the city.
Yeah, exactly. Yeah, it ends up in one place, right? Let me ask you a question about the computation itself within a single node. So if I'm running a node and I'm going out to gather these particles based on a algorithm that I need to run, is that the homeomorphic encryption part where when I'm running the computation, I don't even see what I'm doing? Am I computing genomic data? If I'm computing things, or is that clear text at that time where I'm actually using more normal Python or JavaScript or whatever it might be to actually crunch the data? So does the data in the processing node, the computation node, is that clear text or it's still encrypted? It's
all encrypted. That's the main thing. It's particles, essentially. It's particles and shares. And particles and shares are both information theoretic secure, which means it's the strongest notion of security that you have in cryptography, because it doesn't rely on the computational power of your adversary. So if there's a bad actor somewhere, and they have a strong computer, a powerful one, maybe even a quantum computer, this security ensures that they won't be able to break those particles and actually get the information that they hide. So they're perfectly safe. They could even be published. The only thing that cannot be published are the shares. So each one has to be kept secret by the nodes. But in essence, at no point is any node having access to the plain text inputs. That's the key element, and yet they're able to compute on them and provide an encrypted result.
That's fascinating. I think that's essentially what people want, right? You want a set of nodes that can do computation and detection and judgment call without knowing what is the deal. Like, so one example is like, I want to split the revenue of this music work, but I don't want the nodes to know what is the percentage that Beyonce songwriter have. But that information could be encrypted and made available, and this computation network can figure out what each of the songwriter gets, achieving the ability to stream them money on chain without leaking that information, which if they were to do on the blockchain infrastructure today, there would be a lot of uncomfortable looking across the shoulders like, oh, you got 12%? I thought you only got 15 or like 10 or something like that. So how would a developer or a person who is interested in writing an algorithm that can be executed through this NMC network go about learning the cryptography or writing code that can be translated to this type of encrypted computation within those nodes?
Yeah, so we are working towards making all this complexity that sits, in the cryptographic layer completely transparent to the user, so that as a developer you are presented with a programming language that we call Nada, which is just a DSL on Python. So you would, the look and feel that it would have is essentially Python. But the only difference is that it will have a little bit less functionality at the beginning, but also it will have the addition of having the notion of private and public variables, depending on whether you want to make those values known to the nodes or not. And then essentially you write in that program, in that language, in Nada, it gets compiled into something now more technical. It's an arithmetic circuit or a Boolean circuit. And then that's what the nodes actually run in the network.
Right. Is that related to the type of like ZK circuit generator? Is it similar? Is it exactly the same? Or is it same in some way but different in other ways?
It's very similar. It's in essence the same type of arithmetic circuit or Boolean circuit you would find in ZKP. The only specific difference we have in NMC is that we operate with a basic block that is a sum of products. Instead of just multiplications and additions separately, we kind of put them together in these blocks of sums of products. So there will be some post-processing to the arithmetic circuit you would find from one of these, or you would get from one of these tools.
That makes sense. A lot of sense. It's interesting to see the zero knowledge proof kind of infrastructure in the circuit building, which opens up all new possibility in privacy and even parallel computation used exclusively at this moment for creating centralized sequence EVM compatible thing, right? Without privacy. It's kind of ironic, right? Like you look at it that way. And then it takes a lot of time to explain to people, like, no, what we want is ZK non-EVM. And people are like, what are you even talking about? There might be 4 listeners who understand what we just said, but that is kind of the weirdness. If you begin with zero knowledge as a general category, you would expect it would be in that ZK non-EVM parallel computation thing. But it seems like that's what you're doing.
Yeah, and you could do the equivalent with NMC. So you could have like NMC rollups, and they could operate in 2 ways as well. One is public, like the ZKP rollups currently. So the nodes run the computation, and then they use a threshold signature to agree on the value from that computation, the output. But that computation has taken place in plain text. Or the alternative is that they run that computation in privacy preserving mode. So no node has access to actually the inputs, and they use NMC for that. And then they commit the result to the blockchain. So that's a possibility. But yeah, I get what you get about what you say about ZKP being used in a plain text scenario, which is kind of funny.
Unexpected.
And there's differences between the two. Unexpected. It's a plot twist, definitely. And there's differences between the 2 primitives. It's not that NMC is replacing or MPC is replacing ZKP or vice versa. Their purpose is different. One is for ZKP, the purpose is, okay, I have this data and I want to prove to someone else that data, some property of that data, some claim computed on that data. And I don't want to reveal the data just to make it provable. The problem we're solving with MPC and NMC is different. Is more like that of a compute engine where you can store data, coming from your source, but also coming from other sources, and you can actually compute on it and then reveal results. So whereas in the ZKP setup, the prover has access in plain text to the data, in the MPC setup, no node has access to it.
Right. And it's really interesting, ZKP is zero knowledge proof, right? So there is a class of technology and can be applied different ways. The way we have been, it's kind of like a technique. The way we have been able to like introduce new primitives like that is by analogy, or like a ZK EVM is like a Ethereum virtual machine, except you can validate without a waiting period, and because of the special property that it offers. What would be, for someone who understands cloud computing and the infrastructure, IPFS is kind of like storage and cloud storage, like S3. What would you say that if you were looking at a payload or workload using the NMC network, what is it replacing in the traditional cloud stack? The analytic portion of it, or like a transactional database, or a cloud function type of situation for compute? How does that map to the current internet cloud stack?
So I would say first it replaces the storage part, so the at-rest encryption, because it's done with a different primitive. As I said before, it's ITS, so traditional encryption would rely on some computational hardness assumption, and therefore it may not be quantum safe. But this one is different in nature, but let's say functionally wise is the same. But then the big difference is on the computational part of it. So whereas in a standard cloud environment, you need to decrypt before actually performing computations on the data, which opens a lot of attack vectors, not only against third parties, but also it kind of surrenders your information to the cloud provider. Here, you don't have to do that. You can actually operate on that data while it remains in encrypted form. So every element of a cloud environment that has to do with compute would be different, and would be, in a sense, we would be creating a slightly different version of it that is secure.
Right. Obviously the database is the root of all truth in a traditional cloud environment. Like, databases like Notion and Airtable provides a very user-friendly interface, and they have a database with your data in it, and they can change it, they can delete it, they can read it. More importantly, I can imagine like a company who are very paranoid to not use their competitor hosted product for their own personal internal planning, just because it's hard to not peek at it. You're just relying on a policy, and I can get why people want to do that. So that won't be a problem here, right? Competitors can be using the same network because there's no chance that anybody, an operator, will be able to, even if they run nodes.
That's right. And it also opens an interesting set of use cases around collaboration, because until now, if you wanted to collaborate with a competing company, you had to share data, and no one wants to do that, because it means that you're sharing maybe sensitive information that the competitor can take advantage of. But now, for the first time, you can agree with your competitor or network of competitors to run computations together. Maybe because you want to comply with some regulation. I'm thinking now about banking sector with anti-money laundering, or maybe because it kind of serves everyone to run those computations. I'm thinking now about a supply chain where some optimizations can take place, but no one wants to share information. So there's several reasons for collaboration. I think the current infrastructure of the web, which is client server, has kind of puts us looking at competition always, because it's either you or me, either you have the data or I have it. But now we're looking at the problem from another angle that maybe will foster a lot of collaboration between different entities, because they won't be afraid anymore to share information, because they don't need to.
Yeah, they can share the results of working together with the information without necessarily information being leaked to the public. They can do reconciliation on certain transaction without necessarily telling you the exact either in scope or even out of scope transaction that may benefit a competitor.
They get the insights without sharing the information.
That makes a lot of sense. So let's switch focus a little bit and look a little bit at how this infrastructure is compatible with the current infrastructure that we call Web3, which is, let's say Ethereum ecosystem and all. At the end of the day, a lot of the infrastructure that's been built in Ethereum is about settlement. Okay, now that we've done this computation, so what? And that so what could be someone gets paid, or you get a badge or token or permission or an NFT. You get to join something because of a certain flag turn on and off, or an allow list or deny list. The consequences are basically the on-chain consequences. And it feels really good, right? Because you can build up your transaction and then kind of accumulate through your wallet this kind of either financial assets or social assets. So how does that ecosystem of like gaining, kind of building your identity, fits within this kind of like computation that has nothing really to do with any of it, but could have something to do with all of them? How do you see this computation augmenting the current product market fit of assets and people kind of expanding and growing the assets within Web3?
Yeah. So as we were saying before, there is a side of asset management that is private. Even though you may want this public accountability, there may be aspects of it, like I don't want to reveal my movements, my trading history with anyone, that are better off if they are kept private. And also everything related to the personal information of those sitting behind those trades. And in essence, all of that can now be incorporated into the Web3 decentralized infrastructure as part of it, and it can have the same nice advantages that you would expect from blockchain infrastructure, in the sense that you don't have to trust anyone. It is very hard for any single node in NMC to collude, to gain sufficient power to violate the integrity of your data, or have access to it, or corrupt the system in any way or form. And you can get more fault tolerance that you would expect from a centralized system. So you have in essence all the good advantages of a decentralized network, but now going beyond the public aspect of it into the private one. And in doing that, in a sense, I think we may be looking into merging Web3 with Web2 more than they are currently. Because right now they look like water and oil. They don't mix, because either you deal with private information in Web2, or you deal with public in decentralized, but you cannot do both. And they have remained a little bit isolated from one another, and maybe it has even prevented Web3 from growing larger than it currently is. So we are expecting that to maybe be affected by our technology.
And I think, if you think about the bridge or the merging between Web 2 and Web 3 would be the way Web 3 people, crypto native people, use centralized exchanges, right? You use a centralized exchange in a way as a Web 2 service, and it does some computation, like order books and stuff like that, and it does net settlement, what you deposit, what you withdraw. Could you imagine building like a settlement engine using the NMC technology where it does net settlement for a bunch of people, and then have their kind of trade goes in and they kind of lock their funds a certain way, and they set it out in some time period? I know there's like solution like CowSwap that does that using a solver, but it does it kind of somewhat, continuously, and it's still kind of lean towards plain text, clear text type of settlement or matching. Could you build a matching engine that is private for either simple or slightly complex trades, which then settle out, don't you have to worry about double spend and other things, but for that type of replacement for the CX function?
Yeah, I think in principle it would be possible. As I said, what we're building is aiming for Turing completeness. So in essence, you could build any logic that would lie or sit behind that settlement functional algorithm. And then the nice thing is that you can always interact with blockchains, because you can threshold sign within NMC or within MPC a transaction that is then accepted by the blockchain. So there is a secure way of connecting an MPC network like NMC with a blockchain technology, because we are able to speak the language that a blockchain would expect, which is a DCA signed transaction.
Mm-hmm. So basically, the funds that will be distributed will be in an address, and then the kind of the dispersion or the withdrawal, whatever you look at it, would be signed by a network of consenting nodes based on an output of a computation. And the computation itself has that aspect of secure multi-party computation, but the dispersion is also like a multi-sig that's like, okay, we all agree that we're going to give Miguel $3 or 3 USDC, and that's where the signature happens. And that's part of that same runtime in progress.
Yes, that's right. The only limitation
really
that
cool.
MPC has is around ordering. So if there's anything that requires ordering, then it's a problem that suits or better the blockchain environment, because in a blockchain you get not only consensus on the value of the transactions, which reflect computations, but also in the relative ordering of those. So if you need some ordering in your computations, you could of course build that with NMC, but it's a type of problem that is better suited for a blockchain type of consensus. So that's the only, I would say, limitation that you would encounter. Otherwise, you can run any type of logic.
Yeah, like I think tying back to a use case that we, I sit on the board of a music tech company that works with big labels. There are problems that are, about collecting money from Spotify, and that's an ordering problem. But a lot of royalty processing doesn't require ordering because it's in the past. And you can just say, I'm processing the royalty for March 2022. And we agree what the beginning of the state of everybody's transaction, we agree what the end of it. And there's no ordering. I mean, there's ordering when you withdraw and make sure you get the settlement done. But the computation, it's like in a box, right? There's an epoch, there's a time period where we just look at that. So if it's retroactive, the ordering is less important or not important.
That's it. Not important at all. Think about Web 2. In Web 2, there's no global order of who's doing what at what time. It just doesn't make sense. So what it is a number of computations and taking place independently, and that's fine. That's the way it should be. Because if you add order, then you start opening yourself to attacks based on correlation. Because now you will be able to relate things to one another. Okay, so this happened before that thing, so that's not good for strictly speaking, for privacy purposes. And that's why, in principle, it's not an ingredient of NMC. If you want to do that, you can always connect that using the blockchain in combination with NMC. But we don't want to solve this problem twice. It has been already solved with blockchains. So what we want to do is aim for something new. That is exactly this secure and private compute.
Yeah, I think when people design app products or on top of the Web3 ecosystem, it's very important for the designers and architect to understand the appropriate use for certain tools, as you would if you're a cloud architect deciding when to use a certain type of Amazon service or Google Cloud service. But I feel like, in this particular evolution of our particular industry, people are like, I'm a smart contract developer, everything is a nail, let me see what I can solve with that, and that's all good. But I think as it matures, as people looking at use case, zooming out a little bit, they're going to start wanting these other components, and hopefully the type of people that will be appreciating, like, oh, that looks like a secure multi-party computation problem, or that looks like a privacy preserving kind of computation problem, they can bring it in. And then I see very few organizations, maybe the centralized company, actually pretty smart about that. They use MPC for the wallet management, for their own internal governance and processes and risk management. But when you're talking to people at the forefront in the hackathons, I feel like they barely have enough time to understand all the EIP they have to handle to write secure code. But I'm hoping that as the industry expands and the use case becomes more real in a both a good sense is real use case, and in a bad sense, like those real use cases are hard to solve with just one hammer, that they will come to appreciate the primitive that's being put in place. This is fascinating. I want to touch on one final topic before we wrap up. You mentioned about quantum safety. Now, obviously, we all know that the Bitcoin network itself, assuming there's a certain type of quantum computing, the appropriate one for prime numbers stuff, or whatever it may be that is similar to the attack vector for things. The Bitcoin network itself could not survive unless there is new ways of doing that. what about this particular computation network is quantum resistant, and how does it happen if you're actually governing a network underneath that is not quantum resistant? What is the net output of that, and what's your actual concern in a practical way?
Yeah. So essentially, it's very hard to have an end-to-end ITS or quantum safe network, because there's a whole protocol stack underneath. What we're aiming for is to begin with a layer of our protocol being ITS, which implies being quantum safe. The main reason, or there are several reasons for that. So one is because the actual cryptographic operations that you have to do as a node are simplified when you do that. It's just mere algebra, compared to more complex operations with elliptic curves and things like that. So it simplifies the implementation of the nodes. It simplifies the checking of the security of the protocol. And it also may facilitate the compliance with certain regulations, because you can prove that your information is not being leaked to even a quantum adversary equipped with quantum computers or whatnot. Right. So it helps a lot at that layer. But now when you implement that on a real network, as you say, you're going to have a number of lower cryptographic primitives that are being run there, like signatures and, encryption at point-to-point encryption for the channels. So we want to be very careful there. Yep. It's very hard to aim for information theoretic security, which is one step beyond quantum safety. But we would be happy in settling for quantum safety. And that is our goal. Initially, probably our first version of the network are going to use some cryptography there that is traditional. But we will progress and aim for quantum safety, because I think that is not a matter of when, but it's not a matter of if, but when computers are coming which have such capabilities, and then all these blockchains which rely on that cryptography will be in a lot of trouble. Actually, Web2 as well. So we want to design from scratch for that.
Yeah, I think that's a smart thing to do, because everything seems like more far away in the future, but then when it happens, it hits you really quickly. I think it's happening with generative AI, and whether that's AGI at the beginning of it or it's not really, it does feel like there is a acceleration in progress there. And I think quantum is something that people will. There's enough people working on it that they will feel that. Likely sooner than they would predict if they were to write down on a piece of paper and put an envelope and put it underneath. So can you tell me a little about, obviously this is a very ambitious project. I think we hopefully covered a lot of the core elements that will make someone who is familiar with Web3 an understanding of what this new primitive means. What's your kind of timeline and roadmap in terms of like being able to deliver value to get users and get community around this thing, and also aiming to make sure that you get to the final goal, because the use case does unlock at exponential, if not like exponential scale, if you go from your phase 1 to phase 2 to phase 3. Can you give me a kind of someone who want to follow the project? What are they looking at?
So essentially, well, our strategy is about delivering a series of showcases. Is what we call showcases. It's not really a product in the sense that they may not directly have end users, but rather it's a way of showing the capability of the network, and also creating a reason for us to implement one feature instead of another one. And so we have two parallel paths for development. One is at the language level, which is this NADA language. So we're adding features, more and more features to that language, so that at the end of this path, what we will have is a general purpose programming language that can be offered to developers. And the other track is about the infrastructure. It's about building the network. And there we are starting with a decentralized infrastructure, but we aim for permissionlessness. So we want to get to a stage where almost anyone can run a node. And so we will find several stages and milestones along that path. And obviously the final stage of that is to have the mainnet and with the token running and all of that. So essentially the showcases are also there so that we can attract the community, both of developers, but also of founding entrepreneurs. So those are people who they get an idea from a showcase, or maybe they bring their own ideas and they want to suggest a showcase, and they want to turn that into a product. So they want to they really understand the market, because it would be very hard for us to, for the go-to-market to all of those potential products. We don't pretend to know about everything.
Yeah, for sure.
So it's better to wait for an expert on a particular vertical, a particular market, and take that showcase and make it into a product. And so that is kind of what we expect to, what you can expect to see in the upcoming months is a number of showcases being published. With each one of those, you will see new features coming out and being released, new use cases that are not necessarily the ones that we are used to, like signatures and interoperability, but different things. And then you can, if you're a developer, you can use that to start playing around. And if you're an entrepreneur, you can start maybe thinking about creating Web3 type of products with decentralized compute.
Yeah, it's really cool. And on the website, Nillion.com, there's a bunch of already beginning use case like KYC, gated NFT, voting solution, credit scoring. Those are easily projects that an entrepreneur who have a certain area can take on. But I think hopefully Ethereum show people that, a virtual machine that's Turing complete can do all these things. And the imagination in a blog post that Vitalik wrote about early on his career, trying to evangelize this programmable blockchain, actually all came true. Like all of them, right? Like pretty much all of them.
Yep.
And the one that's at the boundary is because we're running against the protocol stacks within the EVM's limitation within a public ledger and stuff like that. So hopefully the next set of use case, like every S-curve that connects, requires a new technology breakthrough. But hopefully if you zoom out, it's like a continuous development of Web3. And that's why we need both in terms of saturation, in terms of making it user-friendly, the product people stuff, but once in a while, we need a new primitive, and it seems like we have one here. And congratulations of putting the team together and getting the resources necessary to attack this. I'm sure it's not easy, but it seems very, very much aligned with the vision of decentralization, and both in terms of the construction of the network, the sharing of value, and the permissionless of participation. But at the end of the day, we got to get computers to work for us, and hopefully these computers will be working for us and not against us.
Exactly. And we need a solid infrastructure that we can trust.
Yes, absolutely. Computing infrastructure we can trust. Things that when you put in something, you get something you expect. Objectivity right now in software, it was counted upon, and with AI, we have more subjectivity, more hallucination, and hopefully that hallucination is just helping human put their thoughts together, and then we end up still being an objective thing. So I think this counterbalance of the subjectivity of AI and the objectivity of blockchain, while it seems crazy to think about those two things as a counterbalance, but I think they are. AI is human augmentative and not human controlling, right? So we control our keys, we control our future, we control what we do. AI can help us construct our intent, but hopefully the intent is done in an objective universe that's quantum resistant. That'll be so good.
Exactly.
All right. Well, thank you so much for spending time with us today to kind of lay out different aspects of your ecosystem. I invite all of you to read the website and the white paper. It is quite technical. It is a new primitive. It is a new exciting thing. But I think, Miguel, you were gracious to be our guest today, and then gave me a very good overview of how that compare to other things in Web 2 and obviously the emerging Web 3 ecosystem. And as always with the community, we bring builders at the edge of Web 3 and working on real solution, and so that you can see that despite the up and down and the new things and the political wind, we are working towards a decentralized future that nobody else can deny is better than a centralized future of arbitrary decision making by the richest man in the world. Sometimes good. Most of the times that stuff doesn't end well. And hopefully a more objective universe based on mathematics, science, and an understanding, and more importantly, collaboration and participation of human beings being self-sovereign remains to be the goal of the web, the goal of the internet, and we'll continue that journey based on these new building blocks. And thank you very much, Miguel. And to the community, thank you for your time and attention. As always, until next time, take care.